students, welcome back to 60 out of 60 in KSET Chemistry 2025 series in just 200 days. So today we are going to discuss the part 3 of redox reaction, where we'll be talking about redox reaction in titrations and electrodes. Okay, so electrodes redox reaction we have studied in the electrochemistry chapter, but in redox reactions titrations we'll understand in detail. Okay, and one more important thing, please join our WhatsApp channel, link is there in the description section, and this will help you to get access to the PDF notes and our class notes and mock test solutions, all the things. Okay, fine. So now coming to this one, in today's class we are going to do these two topics, that is one second, yeah, that is redox reactions in titration and redox reactions and electrode processes. Okay, now coming to year wise weightage, so this chapter carries very less weightage, or like almost 1 to 2 marks only is there, but definitely this chapter is very important to understand a high weightage topic, that is electrochemistry in your PU2. Okay, so that is why you should not ignore this chapter. Okay, one more important announcement here, students, regarding the PU2 success blueprint test series. Okay, so if you know that like PU2 exams are very near and mock tests are very important, so that is why we are launching this test series, and the first test here will be released on 15th December. Okay, 15th December 2024, and this test series will include 12 tests. Okay, in that there are 4 part tests and 8 full length tests, and in this full 4 part test you will be getting like PC, MB or CS, and then there will be a exam focused question paper with latest syllabus and latest pattern. You will be getting video solutions with detailed explanation, and you will be also getting doubt clarification classes and one shot revision videos before the exam. Okay, so that is why this is very important, and all this you can avail only at a discounted price of 599 rupees only. Okay, so make sure that you take this. So to take that, you can go to the description section, register through this link, and then join this test series. Okay, fine. Now coming to today's class, first this is little I want to explain you about redox reaction and titration. So you should understand that one indicator is something which tells you when the reaction is completed. Okay, and this indicator changes their color in the oxidized form and reduced form. Like for example, if you see, I have something, I will represent it as IN. Okay, IN indicator stands for this one, and so IN has a different form in the oxidized form. Okay, and in the reduced form, suppose you have reduced this IN. Okay, you have gained 2 electrons, it has gained 1 electron, and it is reduced form. It will have a different color in the reduced form. So based on that, the color changes takes place. Now there are one indicator for which we are going to study is a self indicator, and it is about permanganate or MnO4 minus. So let us see what I want to tell you about this. So in some titration, the reagent itself is colored. Okay, and for example, the permanganate ion is intensely purple. Okay, now when it is used in titration, for example, to oxidize Fe2 plus or C2O4 2 minus, so we generally do the titration of permanganate or KMnO4 with FeCl3 or your FeSO4 or oxalic acid. Right, so what will happen? Permanganate ion will oxidize Fe2 plus or C2O4 2 minus. Right, so the solution remains colorless until all the reductant, that is reactant being oxidized, is consumed. So for what is happening here? MnO4 minus is reacting with Fe2 plus. Okay, okay, so now what will happen? Yeah, so now we will have Fe3 plus and Mn2 plus. Okay, so now when till this Fe2 plus is getting consumed, okay, till that this MnO4 will be colorless. Okay, when you put that, it will be color, it like MnO4 is purple in color. Okay, so this is in the burette. So you have like this, a burette is there, and then a test a solution is there. Okay, so when this is put in the solution, it is getting converted to Mn2 plus by reacting with Fe2 plus, and that Mn2 plus is colorless, so that is why we get no color change. Like when you put, it becomes that pink color vanishes, because why? Mn plus 7 is getting converted to Mn plus 2, and Mn plus 2 do not have that purple color. Now what happens? At the equivalence point, when the amount of reactants are in correct stoichiometric ratio, the solution gets a faint pink color due to very low concentration of MnO4 minus. Now what happens when you all the Fe2 plus is oxidized? Okay, so for example, after adding 11 drops, Fe2 plus got oxidized. Now when you add the 12th drop, right, in the solution there is no Fe2 plus, there is only MnO4 minus, right? So due to this MnO4 minus which is present, and we know MnO4 is plus purple in color in plus 7 state. Now there is no Fe2 plus, so MnO4 minus will not get converted to Mn2 plus. So when the drop falls to the solution, it is in the MnO4 state only, or in plus 7 state only. So that is why the solution will become pink. Okay, so that is why what we say, this faint pink signals the end point of the titration. Okay, so this shows that, okay, all the Fe2 plus is now oxidized, and this is the time to stop the reaction. Okay, and only a teeny amount of excess MnO4 minus is needed, ensuring the accuracy. Next, coming to some external indicator, like there are certain indicators which will not be having its own color, right? You need to add one extra indicator for those type of reactions. So in other cases, the reagent does not show a visible color change at the equivalent point. For example, dichromate ion is orange, okay, Cr2O7 2 minus, and does not change the color dramatically during the reaction. Okay, so to detect the end point, an external indicator like diphenylamine is added. Okay, diphenylamine is an external indicator which is added to the reaction. Now how does it work? When all the reductant is consumed, CrO27 oxidizes the diphenylamine, producing an intense blue color. Okay, so now for example, in case of, instead of MnO4 minus, okay, we are having here Cr2O7 2 plus, okay, 2 minus. So this one is oxidizing Fe2 plus, this one is oxidizing Fe2 plus to give you Fe3 plus. Now what happens here, that what we will get here, now we have added one extra indicator here, that is diphenyl. Okay, we have diphenylamine. Okay, now what happens with this diphenylamine? See here, Cr2O7 will oxidize first Fe2 plus. Okay, now after all the Fe2 plus is consumed, we have diphenylamine. So now the diphenylamine will also get oxidized because of this dichromate ion. So when this one gets oxidized, it changes colors to blue. Okay, so when you see blue color, you will automatically know that, okay, Fe2 plus is now consumed. Now the color is because of diphenylamine, and the reaction has to be stopped there. Okay, so okay, this sudden color change signals and it shows the end point has been reached. Okay, now what is the key difference between this one? MnO4 minus act as its own indicator. So in this reaction, you do not have to add any extra indicator, changing the color naturally. But if Cr2O7 is the reactant, requires an added indicator like diphenylamine for a visible endpoint signal. Okay, now there is one more case of iodine also. Okay, let us understand this one. Some reactions like copper, that is Cu2 plus ion, can oxidize iodide ions, that is Cu2 plus oxidizes the iodide ions to give you Cu plus I2. Okay, to produce iodine. The reaction is 2, you can see 2 Cu2 plus, so to balance it, 2 Cu2 plus 4 I minus gives you Cu2 I2. Okay, let me write down the reaction here. Balanced one, so that is 2 Cu2 plus, okay, plus 4 I minus gives Cu2 I2 plus I2. Okay, so copper, what is, if you see the oxidation state of copper here is +1, so itself it is getting reduced, and 4 I minus to I2 it is getting oxidized, right? So that is what the copper does to this I minus. Now what happens, this iodine which is produced in the reaction, okay, that the iodine reacts with the starch to form an intense blue color complex. So now once the reaction has started, and if you add some starch, so the iodine produced in the reaction will react with the starch, and the solution will get blue in color. Okay, now So now what happens, the iodine reacts with the thiosulfate ions in the redox reaction to give you I2 plus 2S2O3 gives 2I minus plus S4O6 2 minus. Here iodine is reduced back to iodide and the thiosulfate is oxidized. As the thiosulfate reacts with iodine, the blue color fades, and because of which the iodine is consumed. Now see what happens. Once you have done, you are seeing that, so how will you know that the reaction is getting completed? Okay, so when you see, okay, when you add the starch, okay, the iodine that is produced will give you blue color. Okay, so from here you can understand that the blue color means iodine has started producing, or the reaction has started. Okay, after that what we do, we add a small amount of Na2S2O3. Okay, so for example, all the reactions has completed, iodine is produced, and then you know that you have to add it with Na2S2O3 or sulfite ions. Okay, now sulfite ions, okay, will react with this iodine back. Okay, so you can see here, sulfite ions will react this I2 again to give you I minus. This one will react this one to give you I minus. Now whatever I minus is produced, so you can see the titration's endpoint is reached when all the iodine, that is I2, has reacted with the thiosulfate and the blue color completely disappears. So now iodine does not react with starch. Okay, iodine in presence of starch gives you blue color. So starch is there, so all the blue color is produced, right? Now when you add sulfite ion, they will react and give you I minus, and when all the blue color disappears, you will know that the reaction has ended. That means all the iodine is consumed. Okay, so that is what is the end point here. So copper reacts, so let me tell you in simple terms, copper reacts with iodide to produce iodine, which turns the blue starch. Thiosulfate removes the iodine, causing the blue color to disappear. The disappearance of the blue indicates the end of the titration, and the amount of thiosulfate used helps to calculate the result. Clear? Okay, now let us go to this one, that is redox reaction in electrodes. So this I think all of you would have studied in your electrochemistry chapter. So what happens when we have a solution, or I can say an electrode with a electrolyte and electrode. One second. So if we have electrolyte and electrode, then what will happen? Okay, so now you see we have electrode and electrolyte. So these electrode can undergo oxidation or reduction. Okay, so the potential difference that is developed between the electrode and the electrolyte is called as electrode potential. Okay, clear? So now here you can see this electrochemical cell or Daniell cell, where we have the zinc rod. Okay, and there is zinc rod and zinc sulfate, so Zn2 plus. Okay, and then we have here copper 2 plus. Okay, copper 2 plus and copper 2 plus will get deposited here. So what is the reaction undergoing here? Zn is forming Zn2 plus 2 electrons. Okay, and copper 2 plus can gain 2 electrons to give you copper. Okay, so this is the overall reaction. So electrode reactions also undergo titration, and because of which we get this type of reactions. Okay, so this is not very important part. So once again I'll tell you about the blueprint test series. I hope all of you know. Just remember the date. The first test is released on December 15th, and you can avail this at a price of 599 rupees. So students, please buy it as soon as possible, because later the price will increase, right? So now till the end of December we are keeping it at a very minimal price. So the registration link is there in the description section. Go there, buy the test series and make the full use, because the first test is coming on 15th of December. Okay, fine. So that's all students in this class. So we have done the redox reaction. I hope you have understood everything. Tomorrow's class we are going to do the previous year questions from this particular chapter. Okay, so make sure that you have revised this and come for the tomorrow's class, so that we can do all the important questions. Okay, so thank you for watching and subscribe the channel for more such videos.